using aerosol duct sealing. Just a couple of housekeeping things before we start. I want to let you know that we are recording today's webinar, and a link will be sent out after the webinar to everyone who either attended or registered but could not join us. So you will be able to feel free to send that link on to other associates that you might like to hear the message that we're delivering today. The second thing is all of you are muted during the webinar today, but we do welcome your questions and hope that you will type them in as we go along if something comes up that you don't understand or have a question about. There is a question pane on the GoToWebinar dashboard. If your dashboard is hidden, you can hit the orange button in the upper left-hand corner, upper right-hand corner, I'm sorry, and your question pane will come open and you can let us know your questions. So without further ado, I am going to introduce our panelists for today's webinar. We have three distinguished panelists. Bobby Seals is the Commercial National Account Director for Aerosol, and he has more than 15 years HVAC experience in both commercial and residential markets, along with experience also in distribution, dealer and sales team management, building optimization, methodologies, and new business development. Bobby has a Bachelor of Science in Pre-Med from Louisiana College, a Bachelor of Science in Environmental Engineering from Louisiana State University, and an MBA from University of Phoenix. Our second presenter today is Matt Diepenbrock. He's the President and CEO of Spring Ridge Partners, a firm that specializes in building, health, and facility optimization. As a registered professional engineer, Matt primarily focuses on health, HVAC, water, and energy-related systems, and he has over 20 years of experience in that field. He received his mechanical engineering degree from University of Cincinnati and also his MBA from the Fisher College of Business at the Ohio State University. Tony First is our third presenter, and he's a mechanical solutions engineer with Brunner Corporation. He has 30-plus years of experience in overseeing all phases of multi-million-dollar construction, infrastructure, and energy projects for government and private sector clients. He has in-depth knowledge of heating and cooling plants and distribution systems, automatic temperature controls, combustion systems and controls, building code, and standard industry practice. Tony has a Bachelor of Science in Mechanical Engineering from University of Dayton, go Flyers, and a Master of Science in Education from Michigan State University. And with that, I am going to turn the mic over to Bobby Seals. Thank you.
Good afternoon, everyone, and thank you very much for coming to the webinar today. I know in some parts, I think we have a couple people all around the world. It might be morning, it might be night. So good afternoon, morning, and night to whatever time zone we are in. Today's agenda is basically in 4 steps. First, the impact of duct leakage. I'm going to do that one. The reasoning that Mr. Matt Diepenbrock undertook this ECM and solution. The results by Mr. Tony First, who actually will share a wonderful project with you. And then we'll go through a little bit of the process and how the Aerosol solution is implemented and executed in the field. So I wanted to first start off with a slide example, and as you notice, you'll see a basic riser diagram made up of the makeup air and the exhaust air. And during new construction or renovation or retro commissioning or anything like that, when we're going to sit down and we're going to balance out the system, all of a sudden we find out that at the very bottom we aren't getting the 40 CFM, as you notice down there on the bottom, out of the, maybe let's call it a bathroom exhaust for a dormitory or hospitality, or even a high-rise building with offices. We aren't getting our CFM out of the bottom. So the tab company goes up in there, and the first thing that they do is they'll change pulleys and shifts to try to reach that CFM. Most noteworthy, the worst case scenario is they'll change motor. And I know of many projects out there right now that are going on that are changing to a higher horsepower. Now then, we all understand the fan loss, and we understand that the energy consumption is the cube to the fan flow. All right? When we did this, we started pulling the building into a slight negative. Now then, when we do something like that, we have quite a few problems that we just created to fix one. We all understand that we have increased the fan energy consumption. We increased the infiltration rate and basically pulled the building into a slight negative. So you know that nice spec that y'all are writing, or maybe y'all we're maintaining ASHRAE standards of, you know, a half air change per hour for a tight building, or 1 air change per hour on a medium building, and 2 air changes per hour on a loose building, right? And we're sitting there looking at our block load, and all of a sudden ASHRAE comes out, probably I think it was October of 2010. They came out with, you know, the air changes per hour really on a building is somewhere around 3 and 4. So now then, what did that do to our plant? Boiler plant and chiller plant. With that, because air and water take the path of least resistance, we've created an indoor air quality problem, because if I'm not getting it out of the bottom, it's pulling from somewhere. And secondly, and lastly, we increased the velocity at the top floors. I mean, I think we have all been in the situation where we are on the, I don't know, call it the 15th floor, and down on the first floor, everything's just fine. But we walk up to the 15th floor, and the next thing you know is, you know, we're getting pulled into an exhaust or getting pushed out by makeup air. So now all of a sudden we'll probably sit down and we'll think, well, yeah, but wait a minute, SEALs, we haven't balanced out the makeup air. Well, okay. Where did it go, Vic? Sorry, folks. There we go. So now then all of a sudden we aren't getting our 540 CFM. So what do? We go back up, change pulleys and shifts. Or worse, we increase the motor horsepower again. So now then we balance it out, and let's say, oh, look, we changed the pulleys and shifts, so some of our infiltration goes away. But still, we have increased the fan energy consumption by the cube to the fan flow. And the last time I checked, we aren't pumping in, let's say, from down where I'm from, New Orleans, Louisiana, we aren't going to be pumping in 95, 78 outside air directly into the corridor. We're going to temper that air. And likewise, if you're up in Minnesota, you're not going to be pumping in negative 50-degree air. So now all of a sudden, if you sit down and you really look at it, a holistic view, and obviously this is the simplest system, right? It's exhaust. You pull it out, you push it in. We have just increased fan energy consumption twice. We've increased plant energy twice. We've created an indoor air quality problem and a comfort issue. So here's your impact of duct leakage. Excessive building infiltration, exfiltration, heating and cooling loads, fan energy consumption, and fan motor heat pickup. And you don't have to take our word for it. You know, here's California Energy Commission public, all right? And even further, we can sit down and we look at, you know, Lawrence Berkeley National Laboratories. New installed systems experience 10 to 30%. And later on in the webinar, Mr. Tony First will talk to you about a new installed system that leaked over 40%, I believe. So with that, I would like to hand over the mic to Mr. Matt Diepenbrock, very well known. And with that, he will go through the reason why he took on the Aerosol solution and process.
All right, thank you, Bobby. Yeah, I remember the first time I heard about Aerosol, my reaction was probably like a lot of engineers, like, yeah, I don't know if that'll really work. So Aerosol obviously was able to change my mind, and that's what they wanted me to talk about today, is how I, how I address some of the questions that I had, and then we'll get into the application later. So why did we choose to utilize the Aerosol process on several of our projects? Well, I mean, it dealt with a lot of different issues, just because, I mean, there's all sorts of air side leakage everywhere, whether it's exhaust systems, makeup air systems, etc. Even in the returns, we've seen issues before. So it'll help address the ventilation, and of course, obviously, we can correct some of the energy problems itself. So, and we also found improvements when we went back and did recommissioning or something. So it does a lot of different things for us. And but even though we would see the benefits of it, is it a product that we could really trust? You know, so yes, we had several concerns. You know, it sounded too good to be true. There was a lot of hype. There's obviously a lot of products out there that have a lot of hype and that never live up to it. So, you know, we were worried about, you know, safety of the materials around people and would it impact any code compliance issues. You know, what about the real-world performance? And, you know, Vicky's a really nice lady if anybody's ever met her, but she, you know, marketing people, sometimes you got to wonder about the numbers they develop sometimes. So, you know, in a perfect lab, the numbers say one thing, but in the real world they might say something else. So that was one of our concerns. You know, how does it impact the overall construction process and schedules? You know, will the contractors be able to work around this? You know, will it cause any problems down the road for the contractors when they're trying to do different pieces of work in the duct or whatever? So we didn't want to be the first ones also. You know, I didn't want to be the first one trying this project out, and then, you know, it turns out to, I don't know, be like asbestos in a system, right? We didn't want to have that happen. So, and then obviously, you know, what about after the system's installed and operating? You know, should we be worried about maintenance? What about, you know, different duct-mounted devices such as smoke detectors and static pressure sensors, and temperature sensors, fire dampers, smoke dampers, etc. So that's just a small list of the items that I brought up to Aerosol and asked them to help me answer those questions. So, well, let's start with the safety and code compliance. You know, we did a lot of due diligence because you know, we don't want to do any harm. You know, we're here to improve people's lives, improve indoor air quality, you know, the comfort of our buildings, etc. So we were very skeptical. You know, the product does meet UL in several different areas, the flame and smoke spread, the mold growth, etc. You know, and then we were saying, okay, well, is it an offensive odor? When you put this stuff in a system, what's it like? Well, I smelled a jug of Aerosol, and it smells exactly like Elmer School Glue. And then when they apply this in a system, because we were on site for a few of these applications early on, and they're little tiny, it looks like smoke when it goes into the system, when they inject it into the duct. It literally looks like smoke. And when it sits on at the edge, it looks like little tiny spherical beads of this polymer that's in there. And the actual product itself it's a vinyl acetate polymer, and it's used in lots of different products in our everyday life, such as chewing gum. So you can put it in your mouth. Bobby, have you ever put it in your mouth?
It doesn't taste like chewing gum.
So yeah, stick to dentine, something like that. But you know, there were no harmful effects, and the EPA also recognizes that. So you know, the product is safe, and that was really one of our primary concerns. So, and then okay, it was able to enhance our ability to meet the ventilation and energy codes. So real-world performance obviously is very, very important. We talked to a lot of people who used it. We verified the results. Aerosol shared the results of a lot of those projects, and then we also used it at a local VA medical center and a pharmacy. And that pharmacy was having lots of problems getting any airflow, staying cool. Heating wasn't the problem, it was cooling, since it was an internal space. So the Aerosol process allowed us to discover system problems that were left over from the renovation project. There was a piece of ductwork that wasn't even connected. It just basically opened into a shaft, and then the other side of the duct on the other side of the shaft was there. So there was no ductwork going across. So we were able to find that. And then we also witnessed the entire process as it was sealing, and it literally got down to 0% leakage, which was unbelievable. It was incredible. So, and the owner was impressed as well, needless to say. And we're actually going to be taking follow-up readings on that specific project over the next several years to make sure that the system is remaining very, very tight. So, you know, because they're going to be doing normal duct cleaning and everything. In terms of schedule impact and coordination, I spoke with a lot of different contractors, and seeing how something like this might impact their work, not only from a schedule, but also a coordination standpoint. And really, we didn't find too many issues. The contractors were pretty flexible when it comes to this. Many of them aren't familiar with it, so they liked the fact that it would help them check the ductwork and the quality of the installation as well. So, we are looking for this right now. We're looking for some new construction projects, because the ones we've done so far have been renovations or retro commissioning type of projects. So anyway, the ductwork, when we do all this stuff, it's pressurized, right? We want to leak check it, and the Aerosol process, you're going to check all of the ductwork, all the medium and high pressure ductwork, not just 25% of it, which is pretty common. So, and there's actually a printout of the leakage as well, so you can prove to the owner before and after that here's the results of the sealing process, and they know that their system is as tight as it can be. And really, the only coordination issue that I would not even bring up, but I mean, like I said, the contractors aren't familiar with it, so just a little bit of training and making sure that the subcontractor agreements and the specs are clear is probably the biggest thing. So there should be no issues there. The commissioning process obviously was enhanced, as we talked about, because everything's actually tested, as opposed to some of the balance reports that come across my desk, like many of yours. It's probably, you wonder if it's done at the bar across the street, so or pencil whipped somehow. So anyway, we want to make sure that this process is being utilized on all the systems. It has the printouts, it has the testing before and after, and we can verify exactly what was done. And in terms of the actual air side of the engineering of the air side system, I wouldn't really do anything differently than what we do today. I would run this airflow calcs the same way right now. Now, as we get more experience with this, we'll probably be able to tighten things up a little bit as well. So, obviously, we didn't want to be serial number 001. We looked at all sorts of different applications, and we didn't want to just use this, in K through 12 projects or hotels. We looked at hospitals. We looked at government buildings and military installations. And we spoke to a lot of different customers in those industries, and every single one gave a glowing endorsement. So that was very positive. And then, in terms of maintenance, we want to make sure that we can clean the ductwork and not disturb the sealant that was in place. And that's been done many, many times with no ill effects. So, the duct cleaning, we use just standard and normal methods. Fire damper inspections, we didn't find any issues there. The duct access doors, some of those fit fairly loose sometimes. The only thing that I would suggest there is make sure that they tape over those with some masking tape or something to, make sure they don't get aerosoled over, but they'd be able to open up very easily even if they did. Duct-mounted devices, fire dampers, smoke dampers, leave them wide open, or block upstream of them if you're concerned about that. I know that I think Aerosol is doing some testing right now in terms of those types of dampers to verify some different things, make sure they don't disturb the fire dampers, smoke dampers. Real world experience that we've had is that we haven't had any issues. Other sensors, I would say like smoke detectors, either remove them or bag them, because the smoke will obviously make the smoke detectors go off. Static pressure sensors, we want to make sure that those are removed because the Aerosol product is very, very effective. And also that's why we want to block coils upstream and stuff, because it causes an issue. So make sure that the VAV boxes are either disconnected or blocked upstream as well. So anyway, bottom line, yes, we approved it. We saw that it was a very good thing. It was a very good option for saving energy on these air site systems. I've never seen anything quite like it. So we were very impressed. All of our questions were answered, and we were able to witness several projects in person, watching them being blocked, watching the process, getting the system unblocked. Contractors were able to bid it competitively, so there were no issues there. And then we also make sure that we created a checklist that incorporates, the pre-sealing and post-sealing items to make sure the system is able to be put back in operation, make sure we didn't miss a block or a sensor didn't get reinstalled or something. So, and I think Tony first now is going to talk about a project that we did about a year ago at a school, and Tony's team did an outstanding job at that project. It was very difficult, and I've never seen a duct installation quite that bad, if I'm able to say that, Tony. So, and they didn't install it. Just to be clear about that too, they came in and fixed it. So I'll turn it over to Tony first.
Matt, thank you. The project was an elementary school here in Columbus, and we looked at a lot of different options to correct this problem. We were brought in actually by the school district's third-party commissioning agent, and because they had such a severe problem, they had tried a number of different things to correct the problem, and they couldn't get there. The building was occupied in 2005. They had a single air handling unit that served the entire building, 50,000 CFM air handling unit, and over the course of time, we actually performed this work last year at this time. They had never been able to maintain comfort in the building. In the summertime, they had routine, it was routine for classrooms to be in the 80s. In the wintertime, it was routine for classrooms to be in the 50s. Go back one slide, Vicki. When you looked at the air handling unit, they could never get the design airflow. The two 40 horsepower supply fans ran all the time at full speed, and they could never maintain 1 inch of duct static pressure in any of the supply duct system. And it was so bad that we were actually pressurizing the return plenum above the ceiling. Next slide. So in coming up with a fix for the problem, one of the things that we were dealt with was this is an occupied building. They were in school. So what were we going to do? How are we going to deal with an occupied facility? Typical school building, ceiling space is at a premium. We had about 3 foot worth of ceiling space above the drop ceiling, and that space was pretty well filled up with piping and ductwork and VAV boxes and cable trays and everything else that architects and engineers want to stuff above the ceiling. The other problem we had was when we were in operation, we had to make the classrooms usable the next day. So we were only able to work from 4 o'clock in the evening until 4 o'clock the next morning, and we had to have the classrooms all usable. So if we took ceilings down, we had to put ceilings back up. So that created some real interesting challenges. And the school superintendent gave us a really tough challenge, is that we weren't allowed to fail. Whatever we did had to work, guaranteed. Next slide, please. So, everybody looked at it and goes, well, how bad could this really be? Well, if you look at the picture, at every duct joint that we had in excess of 2 square inches of hole at every duct joint. The installing contractor failed to install gasketing at any of the duct mate flanges. Next slide. So what we had was, over this entire building, we had a series of large duct leaks. So we came up with 2 different methodologies in how to fix this problem. The first methodology was to come through and seal it up by conventional methods. Basically, get up into the ceiling, take all the ductwork apart, put the gasketing in, do everything the way the original installing contractor should have done. The problem with that is it's extremely intrusive. It's extremely disruptive. There was no guarantee that we would be able to fix every leak in the system. It was going to take an intense amount of time. We estimated that it was a 9-month process, and we had a price tag of over $300,000 to perform that work. We presented Aerosol to the school district as an option at not quite half the cost. We were able to provide them with a 3-year material guarantee as well as a 3-year labor guarantee on the product and the workmanship. It was less intrusive, and we were able to complete it over the 2-week winter break while they were out of school. Next slide, please. So when you looked at all this, what it really came down to is that we reduced their annual energy bill by $45,000. We were able to minimize the loss of airflow in the system. They were losing, we calculated out and verified duct leakage in excess of 27,000 CFM. Now, the duct leakage is less than 2,000 CFM, but 98% of the air is actually ending up in the classroom space. The quote that you see there on the screen, Dr. Wagner, who's the superintendent for the school district, was very skeptical about using Aerosol. His initial description was, gee, it sounds like fix-a-flat for ductwork. And he was really not sure, but that's the route he wanted to go. And after doing some research and talking to some folks over at The Ohio State University, another project that I worked on with Aerosol was a dormitory project, and he talked to the OSU folks. He was convinced that this was the right thing to try. Now that we've actually performed the work, it's been in operation for a year. They are extremely happy. Next slide, please. This is one of the certificates of completion that we turned over. The duct system was big enough, we actually had to break it into sections, partly because of the size of the system, partly because of the leakage rate was so bad we were not able to seal the entire duct system in one process. So we ended up breaking it up into sections. This particular section was one of the supply trunks. We started out, when we first started testing, we had a duct leakage rate in that one section of duct in excess of 3,000 CFM. And over a period of about an hour and a half of applying the Aerosol product and pressurizing that duct, we were able to reduce the duct leakage in that one section from over 3,300 CFM down to 178 CFM. So you can see we were able to provide the test results and a certificate of completion for every section that we did throughout the building. Next slide, please. So when you look at the project at the end of the day, here's what it really came down to. Okay, we completed the project on time and under budget. So from a contracting standpoint, we did everything that we wanted to do. We met our goals for time and budget, which is which ultimately equates to our bottom line. Secondly, we made a happy customer. We reduced their supply duct leakage from 20,000 CFM to less than 1,250 CFM. We reduced it down to a 2.5% leak rate. The original system was 240 horsepower supply fans. By allowing the fans now to be able to operate at a much lower speed, we reduced the total operating fan horsepower from 80 to 34. Next slide. What this really amounted to is we increase the occupant comfort. The kindergarten and first grade wing of the building was so bad in years past, the warmest they could get the building on a 20-degree day was 55 degrees. The kindergartners and first grade teachers are so happy that they no longer have to wear hats and coats and gloves when they're in the building in the wintertime. The building is now, you think about it, 72 degrees is a comfortable temperature. The teachers and the staff in the building are so ecstatic with the performance of the system that they think 72 degrees is too warm. So now they're able to keep the building between 68 and 70 degrees for an occupied condition. They're now implementing their night setback. They were never able to run night setback. The building ran 24/7, 365 because of the fact that they could never recover. They now meet the design airflow. Bobby and I went out and visited the building last year in the end of January, early February. It was 9 degrees outside. The entire building was 72 degrees, and the boilers were actually off because they were satisfied. That condition had never happened in that building before. What this works out to is it's a fan horsepower savings of over $11,000 per year. It's a reduction in chiller energy savings, of $14,000 a year, a reduction of over $19,000 in boiler energy. And because of the fact that we were able to substantiate and prove how much we were able to reduce the fan operating horsepower, the chiller operating energy, and the boiler operating energy, we secured an AEP rebate as a energy savings measure for the school district of $27,000. So if you look at it and you look at the next slide, this slide shows the energy calculations, and this is what we actually submitted to AEP to receive the rebate of the reduction in KW and the actual reduction in energy across the board. And we've gone back and verified this and sat down and compared energy bills from a year ago to this year, and we're within 0.5% of what we calculated the energy savings to be for this district. Next slide.
Thank you very much,
So
Tony.
with that,
Well, thanks a lot, Tony. Appreciate that overview. And yes, that was a absolutely phenomenal project and very successful. And that was at a 40% leakage rate on a total fan flow. And as we all know, and we'll show here in just a second, and what we stated earlier, is that duct leakage is not a matter of do the ducts leak. It's always a matter of how much, right? In this slide right here, I just want to take a moment to go through a little bit of the process, and y'all can read that faster than I can talk about it, but the nice thing that I wanted to point out is the FIMP matrix, the Federal Energy Management Program. We're actually ranked number 3 in the HVAC side, number 8 overall. We have some, nice little accolades here. So a little bit about the process. Number 1, it is patented, it is proven technology. As you noticed in the earlier slide, that it was basically at this point in time, I usually sit down and say, thank you very much for funding us. All right. We were funded by the Department of Energy. We were founded out of Lawrence Berkeley National Laboratories in 1994, came to market in 1997. So it is a patent-proven technology. It cannot miss a hole. It cannot do it. By physics alone, it cannot miss. The question always comes up is, can it seal it? Obviously, this is not nanomite technology. It's a vinyl acetate polymer. We cannot grow ductwork. So if we are actually missing a 2-foot section, true story here, a 2-foot section between the 23rd and 22nd floor, that's going to take some manual fixing. We can't grow it. Okay? So it overcomes all human shortfalls. Now, I believe that nobody goes out there and does a bad job, but we all make mistakes. And it is verified and guaranteed. So a little bit about the process. We're going to take, for instance, this is an upflow air handler, we block this off. Let's say this is hot water reheat coils or VAV boxes or an exhaust grill or any system that we're playing with. We have to make it a closed system. So we isolate the air handlers, we block registers, VAV boxes, hot water reheat coils, and basically seal high side, okay? We have a fan box, heater cylinder, an injection wand, and our computer case. We pressurize the ductwork. We grab a pre-seal leakage test because we have a DG700 in this computer case, and it gives us our baseline. That's how we get our baseline. We start the sealing process. And after we're done with the sealing process, we measure the final leakage, and we print a certificate of completion. So now we go back, and since this is not nanomite technology, and it is a vinyl acetate polymer, how much and how big can it seal? 5/8 of an inch and down is what we put in verbiage. 5/8 of an inch gap can withstand 6 inches of water column. Obviously now we're talking about face area, so 1/8 of an inch of a gap withstands over 20. It does not coat the ductwork, and it seals lined and unlined ductwork. Matter of fact, personally, I have sealed masonry, face brick, stainless steel, drywall, obviously in all types of ductwork, lined and not lined. You do not have to remove most dampers. Dampers meaning that balancing dampers, as Matt alluded to, you just put them wide open. All right, but you must isolate your VAV boxes, because if you give us 12 fins per inch or an airflow measuring station, that's sealed up in a heartbeat. So the due diligence in a retro or recommissioning or any type of energy savings for an existing occupied aging infrastructure building, due diligence is at the utmost in the beginning. So to try to wrap this all up, I'm going to show you a little video here. And this is going to put it all together. Now, this little portion right here, this plexiglass, is just at the very end. You'll see that. Oh, yeah, it does not seal the ductwork. Okay, so we're gonna poke a bunch of holes in this, and because you can't see air, we're going to put some water in it, and you will see it leaking all out. Even over here by the plexiglass, I mean, it's just gushing out. So we blocked off the whole system. All right, and this is exactly what it looks like. Smoke, 3 to 10 microns. Travels down the ductwork, and it goes to only the place where we have created the velocity between pressures. So if you notice all the little substrates, it's kind of like, call it platelets, if you will, right? It's going to go, it's going to form a scab over it. So now then you can see that there is no leaking anywhere, right? Not even around the plexiglass. So at the very end of this, to show you that it doesn't coat the ductwork, we're going to drop a little goldfish in here, and it's clear. So what is this? As Matt stated, it is a vinyl acetate, basis of chewing gum, hairspray, water-based paints. We had to undergo the same longevity test that mastics and tapes do, and gasket and everything else, and the DR over DT is 40 years, and we last that long. There is no VOC off-gassing, none, after 2 hours. Now, when we say 2 hours to cure, this does not become hardened. It doesn't, it's not like hard cast or anything like that. It maintains its elasticity. Okay, so as the ductwork expands, contracts, minuscule in some instances, it will still expand and contract with it. It has the UL that you need, has the ASTME, and meets the 90 NFPA 98 standards. And there is a 3-year commercial application guarantee. So this is the fan box, heater cylinder, injection wand. So basically what we have here, and there's your computer case over here, we have the gallon jug sitting in the fan box. It is pumped out of the fan box into the top of the injection wand. All right? With this right here, we only have 3 moving parts of the system: a fan, a solenoid valve, and a pump. And the pump is an IV pump, basically. We only pump at a rate of 1.4 to 1.6 cc's per minute. So we use very little sealant. All right? Now then, obviously, if you put a liquid up underneath heat and pressure, we pull the liquid out and we atomize it. That's how you get to the 3 to 10 microns, basically the smoke look. Now then, as you see the injection process here, all right, you'll see that this is an internal injection, so we got a 14-inch round collar. We're actually using an access door, all right? And in these instances, you see that, well, it can make bends, it can make turns because, it looks like smoke and behaves like smoke. And then you'll see here on this one right here, this is your exhaust fan right here, and I'm using the doghouse. Now, in most instances, as you see, this is like exhaust shafts. We like to use gravity. We like to inject top down. No reason to go against it when we have it working for us. Okay? So we like to inject top down. So now then, how do you block it? Here's a high-density cell phone blocking material that we use. Okay, and this would be like high-side VAV. Over here is just a regular returner or supply grill. Right here actually is a 6-foot by 7-foot exhaust header. Now then, I have used masonite, plywood, sheet metal, panning, our high-density cell phone blocking. The whole intensive purposes is to create a closed system. Then we start the sealing process. We measure it in the pre-seal leakage. We begin the sealing. So what we have here is we have a technician at the computer screen, and other ones are walking around the building or around the air distribution system that we are sealing at that time to ensure that everything maintains stability, so we don't blow out blocks or anything like that, okay? And then if we do, because it is so fine, it actually, you just put in portable scrubbers or grab a remediation fan at 3,500 CFM and you scrub it out because it looks like whispers of smoke. First you'll smell it, as Matt stated, and then you will see it, all right? And it looks like whispers of smoke, and all you do is just scrub it out. So you monitor the sealing progress on the computer. You monitor it during the sealing process in the spaces, and then we do a post-seal leakage test. Now then, this is the computer screen that we look at, the technician does. So you notice here, this is at 25 Pascal or 0.1 inch of water column. We're over 400 CFM, all right? If we're at 1 inch of water column, that would be equate to probably close to 1,600 cubic feet per minute of air going somewhere where you didn't intend it to go. Now 1,600 CFM, I mean, 400 CFM is 1 ton. 1 ton is 12,000 BTUH. So now we're talking about some energy. And you notice that we sealed this in less than 12 minutes. So when we sit down and Tony showed you the printed certificate, CFM reduction, BTU, you got energy savings. And these are just some of the installation of examples. Now, obviously, we have hundreds and thousands of these, but there isn't really a market that we haven't been in and haven't sealed in. Where there's duct work or an air distribution system, it can be sealed. And now there are 2 places that you do not utilize the aerosol process or the aerosol solution. One of them, it is water soluble. Therefore, please do not think that we're going to do industrial kitchen hoods. All right. A couple things. One, if it's a greasy kitchen hood, it's not going to stick. All right. Number 2 is that you're hitting it with about 15,000 psi on it, and you're scrubbing the heck out of it. Right. So it's totally different than air side. Okay. And on top of that, it's supposed to be explosion proof. The other one is like if you go down in like maybe the Georgia area, the Carolinas, you have some in-slab duct work, trying to keep out an aquifer. It is water soluble. Now then, high humidity, not a problem. It's the standing water alone. So if you sit down and you think back on that video, eventually that fish would die just due to the fact that the little substrates would dissolve over a period of time and the water would leak out and then the fish would basically suffocate.
I never thought of that.
So it is water soluble. So if it goes anywhere or gets on anything, just some elbow grease and some warm soapy water and it comes off. Okay? Now then, with duct work, again, the standard methods of cleaning, not an issue, not a problem, just standing water alone. And with that, thank you very much. And I know for some of the ESCO companies that are sitting out there and the energy engineers out there that, if you have a project out there, I mean, we're doing a lot of work with ESCOs right now. If you have a project or thinking about a project that you might want to utilize the Aerosol as a good ECM measurement, please feel free to give me a call, and we'll talk about a level 1 or 2 energy audit.
All right. Thank you very much. We've had some questions coming in on the line here while you guys have been talking, so let me throw the first one out. It's from Don, and he's asking, how does it work with reheat coils?
Let me take that.
Sure, because I can't.
Hi, Don. This is Bobby. Buddy, if you give us 12 fins per inch, it is done. There is not amount of, and Tony, you can even chime in, there's not enough combing that you can do to take care of it. So in the beginning, if we have VAV boxes, hot water reheat, steam reheat, humidifiers, whatever we have in there, we block it. So we will actually, like hopefully I showed in that process portion, is that we block and seal high side first. And then you sit down and look at the mechanical feasibilities of it. All because we can seal it doesn't mean that we should sometimes. Okay. Oh, sorry, Don. You answered this. Got you, buddy.
All right. We have another question. How much ductwork can be sealed at one time? I'm not sure who that one's from. It came in on the chat window. Is there a limit?
Well, hi, it's Bobby again. With one fan box, obviously we're talking about volumetric pressure, volumetric flow rate, okay? And with one fan box, we can do probably, what I would say is about 100 to 150 linear feet, okay? Obviously, if we use gravity, we're going to be doing pretty good here. But what we do is if we have to have more volume or more length, we can actually take and parallel or double up, if you will, fan boxes. In some instances, we've actually used the air handlers themselves. We just finished a project up in Rochester, Minnesota that had an 8-foot by 10-foot by 80-foot header section, about 300,000 CFM. And we utilized a couple of those 75 horsepower fans to create the volume and pressure that we needed. Other than that, like Tony, usually the leakage is so great that, you know, we'll be probably putting it into sections.
But which is what we did on Licking Heights. We just broke it up into sections and went down the various corridors. And it's a little hard to see without seeing the ductwork. Without a duct plan, I probably should have put a duct plan up on the screen, but if you can imagine a typical elementary school finger design, we had a main trunk down the main corridor, and then the branch fingers off of it. We just broke it up into sections.
Hey, Tony, we had another question come in for you. They were very impressed with your astounding measurements at Licking Heights. Is that a common example? And they wanted to know if you've done any follow-up measurements over the year to validate your energy numbers.
Yes, we have done follow-up measurements. The commissioning agent is a firm based out of Dayton Heapy Engineering. They have kept track of the energy numbers, and they have validated the energy numbers continuously over the past year. I would not necessarily classify that building as typical. Typically, we see duct leakage, the jobs that we've done, in the 25 to 30% range. That building was pretty excessive at almost 50%. Fortunately, they're not all that bad. But we're actually looking, trying to work with the school district and work with them on doing some others out there. But they're in a construction mode right now, so we're working with them to do some stuff on some new construction right now.
Awesome. The next question was for Matt. It said you mentioned a checklist on projects. What are some examples of items that could be missed on that kind of thing? And do you have any examples of a checklist?
Well, the checklist that we use on our projects, we have a master checklist we've developed, and we break it into pre-sealing, and then sealing event itself, and then post-sealing. Some of the pre-sealing events or pre-sealing checklist items are make sure that you understand what the ductwork is, how it's actually built, not just how it's drawn on the drawings, and then making sure that all the devices are blocked properly. Temperature control, smoke detectors, things like that are removed or bagged to make sure that they don't get filled up. Let's say VAV boxes, make sure those are blocked, coils are blocked, humidifiers, etc. So those are some of the pre-sealing events. During the sealing process itself, I believe some of the items in our checklist would include, making sure somebody is monitoring the computer itself, so in case there's a problem, they can shut it down. The injection, they can shut the injection down. But you also have people walking around making sure there's not some gaping hole somewhere and all this stuff just leaking out. So you inspect the space during the sealing process, and then post-sealing you want to make sure that we return the system back to operation. So we have to remove all the blocking materials, make sure that temperature control devices are put back in place, smoke detectors are put back in place, but also the fire alarm system is turned on too if you happen to turn it off. So that's the reason we made a checklist to make sure that the system goes back in proper working order. If somebody wanted to, we could show them an example of what we've done for our checklist. It's really not that big of a deal, and they can request that from myself or from Bobby. So yeah, that's
okay.
A good question.
Great. Well, we've had somebody join us from Australia, down under. Hi, Jeremy. Jeremy said he is interested in how you utilize the AHU fan to pressurize the system you just mentioned. I don't know if did you just mention that? Okay, so that's a real-time question. So can you explain this?
Well,
is it too long of an answer?
Hey, Jeremy, how you doing, bud? Nice to see you, for starters. How about you and I catch up at a later time, and I'll answer that specifically because it involves separating it out, cutting some holes, face areas, making sure we pressurize, and then also what does it do to the certificate, right? So there's a lot of things in there, but those are extremely, we were talking about a 10-foot by 8-foot by 80-foot header, 300,000 CFM header at a very wonderful clinic in Rochester. So it was fun to do, by the way, and I'll be more than happy. Just give us a call. Give me a call anytime.
We got a good question. We've got a couple of budgeting questions. Gretchen wanted to know who typically pays for this when it's a remediation problem. The owner, the ductwork subcontractor? Question mark, question mark. Does it vary?
I would say, this is Matt, I would say that it varies. If there's a specification issue and, and it was maybe poor workmanship for some reason and the owner and the engineer wanted it rectified, I would think that it would fall upon the contractor. We don't see that really that often.
I don't want to pull out the old engineering proverbial statement, it depends.
No, it does
but it does depend.
Oh, that sounds fair.
Most of the time the owner pays for these projects.
The owner,
that's
building owner.
Well, but in the ESCO world, this is underneath an energy conservation methodology, and they've got their own contract in place on guaranteed savings and stuff like that, right? So,
someone else was wondering, what is a typical budget cost to apply Aerosol? I have a feeling the depends answer is coming again. And what are the typical savings?
Wow, Tony, Matt, I'll start this, and y'all correct me if I go awry here. But normally, in the ESCO realm, is that Aerosol will be sitting usually right around $2 to $3 on for instance, an existing VAV system. All right, because it's all labor. This is mainly labor intensive, and depending upon your labor rates in your area, it could bump up to 3 to 4. All right, if we're playing in the $120 an hour labor rate versus, you know, a $50 an hour labor rate, that's going to vary a lot as far as like a price per CFM. Okay. Also on top of that, I explained that that was a VAV system. If you do an exhaust or make-up air, the labor is not intensive, right?
It should be simpler.
It's a lot simpler. You aren't going up above ceiling and you aren't doing this and blocking VAVs. You're just going to a 4x6 exhaust grill and blocking it. So the labor is less intensive. So the price per CFM would be less, but then again, it depends. And I know that's the proverbial engineering statement. So now then, what does it usually range in a simple ROI aspect? Depending upon, you know, if we're using national averages at 12 cents a kilowatt, $1 a therm, and, you know, a decent occupancy schedule, you're looking somewhere probably less than a 3-year simple ROI, maybe 5 max probably on exhaust makeup air. Yeah, on a simple ROI. And Tony's example, I think yours came out to be right around 5 years, Tony, somewhere around in there.
We paid, and our project at $170,000, we corrected a couple other issues in that project with some failed turning vanes and some other things that we found, and we still ended up with less than a 5-year ROI, not including the utility rebate.
Yeah, I was about to say, that's not even including the AEP rebate on that one. So, you know, exhaust probably 5 and under, typical VAV, probably around 8 years and under. And that's with high labor rates, by the way.
So the only thing I would say about the budget is what we've seen so far is budget just a tiny bit more. I would go $3 to $4 a CFM for a VAV system, because what we find is you need to trace these systems out, make sure that it was actually installed. It's never installed like it was shown on the drawing. So there's some additional time that actually is eaten up from doing those types of inspections. So you need to account for that.
I agree with that. I mean, we're dealing with a couple of stuff in New York and all over the place that we can't even get the plans, right? I mean, heck, we got probably a 25% shot of getting as-built. And on top of that, even the as-built, you never know if somebody took a 6-inch round or 8-inch round off the main header and it's going to a, I don't know, closet or something.
Okay, well, thank you. We're just a few minutes past what we promised. We wanted to keep this to an hour, and we're just a few minutes past. We didn't get a chance to get to all the questions. I know Randy had a question on ROI. I think you were just addressing that. There are a few others, but we will definitely have someone get back in touch with you to make sure that all your questions are answered regarding this. And I thank you for participating in the poll that we've got open on your screen. If anybody else would like to weigh in before I close that out, that would be great. And other than that, Bobby, if you have any last words for our audience, I do, again, want to thank you guys for joining us this afternoon and hope that this was helpful. Watch for a survey from Aerosol Marketing in your box tomorrow so that you can give us any feedback on today's presentation.
Yeah, for starters, thank you all very much for spending time with us today. And also thank you very much, Matt and Tony. It's been a pleasure. And with that, thank you all.
Thank you. Have a good afternoon and a nice holiday season.